The 1882 Crossley SN4484, a 3.5 horsepower slide valve gas engine, recently saw its very first startup following an extensive and careful restoration. This machine, built in the early days of internal combustion, represents one of the pioneering designs of stationary power. After months of work, every part was remachined, cleaned, and reassembled, leaving the engine in excellent condition, but naturally very tight in its bearings and slide valve gear. For this first trial, the engine was set up to run on hydrogen, serving both as the ignition source and as the primary fuel. Hydrogen provides a clean and responsive burn, but with a freshly restored engine, the challenge was not fuel, but simply getting the crankshaft to turn freely enough for proper firing. At the first attempt, compression and valve timing were carefully checked, and flywheel effort was applied to overcome initial stiffness. Each rotation carried the weight of new bearings bedding in and freshly fitted components settling into place. Though difficult to coax into motion, the startup marks an important milestone. The Crossley, silent for over a century, is once again showing signs of life, a testament to early engineering and the dedication of those keeping this heritage alive. The Otto and Langen free-piston atmospheric engine, first exhibited in 1867 at the Paris Exposition, is often regarded as the world's first commercially successful internal combustion engine. Unlike later four-stroke designs, it worked on the principle of atmospheric pressure. Combustion sent the piston upward, and the return stroke was powered by the air rushing back in, rather than by direct combustion force. Starting one of these machines was no small task. Operators had to carefully introduce a gas-air mixture, ignite it with a flame ignition system, and guide the piston to ensure it caught properly on the rack and governor system. Once running, its tall, distinctive flyball governor would regulate the irregular explosions, producing the characteristic hit-or-miss rhythm. At the Rough and Tumble Engineers Historical Association show in Kinzers, Pennsylvania in 2017, visitors were able to witness a reproduction of the original 1867 Otto and Langen engine in action. Built with painstaking attention to historical accuracy, this reproduction vividly demonstrated the challenges faced by early engineers. The slow, deliberate starting process, requiring strength, patience, and a keen understanding of timing, contrasted sharply with the effortless turn of a modern ignition key. Seeing it come to life offered a rare glimpse into the dawn of internal combustion, where each explosion marked a step toward the modern age of power and industry. A V8 1.2L engine is an extremely compact and unconventional configuration, combining 8 cylinders in a very small displacement. Typically experimental or conceptual, it emphasizes high revving capability and lightweight design over raw power. Such an engine highlights engineering creativity, prioritizing efficiency, packaging, and performance innovation over traditional large-capacity V8 strength. The Wright R975C4 engine was a 9-cylinder, air-cooled radial engine developed by the Wright Aeronautical Corporation in the 1920s and 1930s. Part of the Wright R975 Whirlwind series, the C4 variant was widely used in both military and civilian applications due to its reliability and relatively compact design. With a displacement of 975 cubic inches, about 16 liters, it produced around 300 to 400 horsepower depending on configuration. The engine featured robust construction, simple air cooling, and ease of maintenance, making it a favorite for rugged operations. The R975C4 became especially well known for powering the M3 Lee and M4 Sherman tanks during World War II, where its durability and proven design ensured dependable performance in harsh combat environments. Beyond armored vehicles, it also found use in some aircraft and training planes. The Wright R975C4 remains a notable example of early American engineering, bridging aviation and ground warfare technology. The Allison V1710 V12 engine was a liquid-cooled aircraft power plant developed in the United States during the late 1930s and widely used throughout World War II. Officially designated the Allison V1710, it was a 12-cylinder, 60 degrees V-type engine with a displacement of 1,710 cubic inches, 28 liters. It was the only mass-produced American liquid-cooled V12 engine of the era and became the backbone of several prominent U.S. fighter aircraft. The V1710 was initially designed to provide a reliable, powerful engine for military aircraft that could be easily adapted to multiple airframes. Depending on the variant, it produced between 750 and over 1,600 horsepower. Early versions powered aircraft such as the Curtiss P-40 Warhawk, Bell P-39 Airacobra, and Lockheed P-38 Lightning. Later refinements allowed it to be fitted with turbochargers and superchargers, improving high-altitude performance, particularly in the P-38. Known for its ruggedness, smooth operation, and adaptability, the Allison V1710 played a critical role in America's wartime aviation industry. Although often overshadowed by the Rolls-Royce Merlin, especially in the P-51 Mustang, the Allison remained a dependable workhorse that contributed significantly to Allied air power. The 1938 D7 Caterpillar engine was part of Caterpillar's line of medium-sized track-type tractors, introduced during the late 1930s as a reliable workhorse for construction, agriculture, and military applications. Powered by a Caterpillar diesel engine, the D7 quickly earned a reputation for durability and efficiency at a time when diesel power was still becoming widely accepted. Its engine featured a unique starting engine system, often a small gasoline pony motor that was used to crank and warm up the larger diesel engine before operation. This design helped overcome the challenges of starting heavy diesels in cold weather, a common issue in that era. The D7's engine delivered strong torque at low speeds, making it ideal for pulling scrapers, plows, and other heavy implements. Its rugged build and dependable performance allowed it to handle grueling tasks such as land clearing, logging, and road building. During World War II, the D7, with its reliable Caterpillar engine, became a critical machine for military engineers, building airstrips, roads, and fortifications across varied terrains. Today, the 1938 D7 Caterpillar engine is remembered not only as a technological milestone, but also as a symbol of Caterpillar's long legacy of building machines that shaped infrastructure and industry worldwide. A Bentley chassis fitted with a Rolls-Royce 27-liter V12 Merlin, or its tank-derived Meteor variant, is the ultimate expression of British motoring excess. The Merlin, famed for powering Spitfires, Hurricanes, and Lancasters during World War II, is one of the most iconic piston engines ever built. In Meteor form, stripped of superchargers for reliability in tanks, it retained immense displacement and raw torque. Marrying such a power plant to a pre-war Bentley chassis transforms a gentleman's touring car into a thunderous road-going monster. These hybrids, often created by skilled enthusiasts rather than manufacturers, embody engineering audacity. The 27-liter V12 dwarfs the original Bentley engines, producing over 600 horsepower and monumental torque in naturally aspirated meteor form, with Merlin derivatives capable of far more when tuned. The result is a machine capable of immense acceleration despite its size, accompanied by a soundtrack more akin to an aircraft than an automobile.
Driving such a car is less about refinement and more about theater. The towering bonnet, the physical effort of harnessing so much power, and the sense of commanding a mechanical leviathan. These creations are part rolling sculpture, part engineering experiment, and a living tribute to two of Britain's most storied names in automotive and aviation history. The restored Tatra 603's air-cooled V8 engine embodies both engineering heritage and renewed vitality. Its rear-mounted 2.5-liter power plant, once a symbol of Czechoslovak innovation, now runs with smooth precision and unmistakable character. Restoration revives its unique sound, cooling efficiency, and enduring charm, blending historical authenticity with modern reliability. The Tatra T815 V10 diesel engine is a robust, air-cooled, turbocharged power unit developed for the Tatra T815 heavy-duty trucks. Featuring a 90 degrees V10 configuration, it delivers high torque output across low RPM ranges, making it ideal for off-road, military, and construction applications. The engine's air cooling system eliminates the need for liquid coolant, reducing maintenance demands and ensuring reliable performance in extreme climates. Known for its durability, the V10 provides power ranging from 230 to over 440 horsepower, depending on configuration. Its modular design allows easy servicing, embodying Tatra's tradition of building engines for rugged, long-lasting performance. The Tatra 815 T2 engine is a robust, air-cooled, turbocharged diesel power unit designed for the legendary Tatra 815 heavy-duty trucks. Known for reliability in extreme conditions, it features a V12 configuration with direct fuel injection, delivering strong torque and high endurance. Its air-cooled system eliminates the need for a radiator, reducing complexity and enhancing performance in harsh terrains such as deserts, mountains, and polar regions. The T2 engine was widely used in military, construction, and rally applications, including the Dakar Rally, where Tatra trucks proved their durability. It remains a symbol of Czech engineering excellence. The Tatra T3-929 to 30 volts 10 engine is a robust, air-cooled diesel power plant developed by Tatra for heavy-duty trucks and military vehicles. Featuring a 17.6-liter displacement, its V10 configuration delivers excellent torque and reliability. Known for durability in extreme terrains, it embodies Tatra's signature backbone tube chassis integration and long-lasting engineering heritage.
The Lister D engine is one of the most iconic stationary engines produced in Britain during the early to mid-20th century. Manufactured by R.A. Lister and Company of Dursley, Gloucestershire, between 1926 and 1964, it became renowned for its reliability, simplicity, and versatility. Designed primarily for agricultural and light industrial use, the Lister D was a small, single-cylinder, four-stroke engine available in both petrol and petrol paraffin versions. With power outputs typically ranging from 1.5 to 3 horsepower, the Lister D was not a large engine, but was more than capable of driving essential farm machinery, such as water pumps, cement mixers, sheep shearing equipment, milking machines, and small generators. Its straightforward design made it easy to maintain, while its robust cast iron construction ensured durability even under tough working conditions. Farmers and tradesmen valued the engine's economical running and dependable starting, which often came from a simple hand crank mechanism. Over the decades, hundreds of thousands of Lister D engines were built, and they became a familiar sight across rural Britain and beyond. As technology advanced and mains electricity became more widespread, demand for stationary engines declined, and production eventually ceased in the mid-1960s. Today, the Lister D is highly prized by vintage machinery enthusiasts and collectors. Restored examples are regularly displayed at steam fairs and agricultural shows, where their steady, rhythmic pop-pop sound evokes a bygone era of farming and rural life. Its legacy as a rugged workhorse has ensured its place in Britain's engineering history. The steam turbine is a mechanical device that converts thermal energy from pressurized steam into useful mechanical work, which can then be used to generate electricity or drive industrial machinery. One notable design is the Paxton turbine, a low-pressure steam turbine capable of operating at full load with a steam pressure of just 200 kilopascals. This makes it versatile, as it can be easily integrated into a wide range of steam circuits to produce process power efficiently. The Paxton turbine is especially adaptable because it can utilize almost any thermal source. Fuels such as coal, gas, biomass, bunker oil, or synthesis gas can generate the required steam. Additionally, renewable energy sources like solar thermal and geothermal can be employed, making it an environmentally friendly option in sustainable energy systems. Unlike traditional high-pressure turbines, the Paxton turbine's low-pressure design simplifies operation and reduces stress on system components, thereby lowering maintenance requirements. Its compact design allows it to be installed in industrial plants where excess steam is available, turning waste heat into valuable power. With its broad fuel compatibility and reliability, the Paxton turbine demonstrates the efficiency and flexibility of modern steam turbine technology in diverse energy applications.
What's the pressure done?
ChatGPT da noi. The Alstom AHK 4228 PL Stick Engine Cold Start Process riferisce all'iniziale running di questo Large Marine Diesel Engine under low temperature conditions. La 4228 serie, based sul PL Stick design e manifatturato under license by Alstom, è widely used in navale e commerciali vessel per its reliability e power. Cold starting such an engine requires careful preparation, including pre-lubrication, heating of cooling water and fuel systems, and controlled air starting to ensure smooth ignition. Without these measures, cold metal surfaces and viscous lubricants can cause high wear, poor combustion, and starting difficulties, affecting efficiency and engine life. Class 37 locomotive number 37714, named Cardiff Canton, is a preserved example of the English electric Type 3 diesel, affectionately known as the tractor, thanks to its distinctive growl. Built in the early 1960s, this 1,750 horsepower locomotive was one of a large fleet that became a mainstay across the British rail network, hauling both heavy freight and passenger services for decades. Today, in preservation, locomotives like 37714 remain popular with enthusiasts, not only for their heritage value, but also for the visceral experience they provide when fired up from cold. A cold start of Cardiff Canton is a dramatic event in its own right. After sitting dormant, the engine requires careful preparation. Batteries are engaged, fuel pumps primed, and systems checked before the 12-cylinder English electric power unit bursts into life. The startup sequence is accompanied by clouds of exhaust and the unmistakable chugging rhythm as the turbochargers spool and the engine settles into its distinctive idle. For many, this is the most exciting aspect of diesel preservation, the raw sound and spectacle of machinery coming alive after rest.
The locomotive's association with Cardiff Canton Depot, once a key base for Welsh diesel operations, adds to its significance. In preservation, 37714 ensures the memory of that era is not only kept alive, but also experienced in full sensory detail.
At the 2013 Nuenen 25th Anniversary Show, one of the standout demonstrations was a large 19th century reciprocating horizontal sawmill powered by a mighty 30 horsepower Thomason diesel engine. This impressive exhibit captured the attention of enthusiasts with its combination of historic machinery and raw mechanical power. The saw, originally designed for heavy timber work, showcased the precision and endurance of industrial engineering from over a century ago. Driven by the steady thump of the Thomason engine, the long blade moved rhythmically back and forth, cutting through large logs with remarkable efficiency. The sheer scale of the equipment, combined with the deep, resonant exhaust note of the diesel, created a captivating spectacle. Visitors were reminded of the ingenuity and durability of early sawmill technology, as well as the skill required to operate such machines. It was both a working tribute to industrial heritage and a highlight of the show's engineering displays. The Fairbanks Morse 15 to 25 horsepower tractor was one of the early machines produced during the transition from horse-drawn farming to mechanized agriculture in the 1910s and 1920s. Built by the Fairbanks Morse Company, well known for engines and industrial equipment, this tractor embodied the company's efforts to enter the competitive agricultural machinery market. Rated at 15 horsepower on the drawbar and 25 horsepower on the belt, it was designed to serve medium-sized farms, providing sufficient power for plowing, threshing, and other heavy field work. The tractor was powered by a two-cylinder opposed engine, a design that Fairbanks Morse had perfected in its stationary engines. This configuration provided strong torque and relatively smooth operation for its time. The machine was kerosene-fueled, as kerosene was cheaper and more widely available than gasoline in rural areas. Its large steel wheels, fitted with lugs, gave it traction in fields but limited its comfort on roads. Although reliable and rugged, the 15 to 25 horsepower tractor was produced in relatively small numbers compared to competitors like John Deere and International Harvester. By the late 1920s, Fairbanks Morse shifted focus back to engines and industrial equipment, leaving tractor production behind. Today, surviving examples are prized by collectors as rare reminders of early American tractor history. The Enfield twin-cylinder diesel was a unique motorcycle developed in the late 1960s and early 1970s, primarily in the United Kingdom. Built by Enfield of Redditch, it was one of the earliest attempts to combine the rugged reliability of a diesel engine with a motorcycle frame. The machine was powered by a 325cc parallel twin diesel engine, producing modest power but offering exceptional fuel economy, often exceeding 150 miles per gallon. Although heavy and relatively slow compared to petrol-powered bikes, It gained popularity among enthusiasts who valued efficiency and long-distance touring on a budget. Its agricultural roots and distinctive thumping sound made it stand out in the motorcycling world. Production numbers were limited, and it never reached mainstream success, but today, the Enfield twin-cylinder diesel holds a special place in motorcycle history as a rare and innovative experiment in alternative motorcycle propulsion. Collectors and diesel bike fans regard it as a curiosity worth preserving. Its agricultural roots and distinctive thumping sound made it stand out in the motorcycling world. Production numbers were limited, and it never reached mainstream success. But today, the Enfield twin-cylinder diesel holds a special place in motorcycle history as a rare and innovative experiment in alternative motorcycle propulsion. Collectors and diesel bike fans regard it as a curiosity worth preserving. The McDonald S-type tractor was a robust Australian-built machine, popular during the mid-20th century for its simplicity and reliability. Designed with a single-cylinder diesel engine, it was known for its slow, rhythmic chug and remarkable pulling power despite modest horsepower. Farmers valued it for its durability in tough working conditions and ease of maintenance. A distinctive feature was its ability to run quite well on straight diesel fuel, making it economical and practical in rural areas where fuel variety was limited. Today, the McDonald S-Type is remembered fondly by collectors and enthusiasts as a true workhorse of its era. The Hornsby Akroyd patent safety oil engine, developed in 1891 by Herbert Akroyd Stewart and manufactured by Richard Hornsby and Sons in England, was a groundbreaking internal combustion engine. It was the first practical oil engine to use vaporization rather than carburation, allowing it to run on heavier, cheaper fuels like kerosene. The design employed a separate vaporizing chamber, heated by the engine's own combustion, to ignite the fuel-air mixture through hot bulb ignition. This eliminated the need for external flames, making it safer and more reliable than earlier engines. The Hornsby Akroyd engine played a crucial role in transitioning from steam to internal combustion power, influencing later diesel development and marking a milestone in industrial and agricultural machinery. The Lister JP4 is a classic four-cylinder marine diesel engine, part of the renowned Lister JP series introduced in the 1930s. Known for reliability, smooth running, and distinctive exhaust note, it was widely used in narrowboats, fishing vessels, and industrial applications. Today, it's cherished by enthusiasts for heritage and durability. Ruston and Hornsby was a prominent British industrial company, best known for its internal combustion engines and engineering innovations in the late 19th and 20th centuries. Based in Lincoln, England, the firm emerged from the merger of Richard Hornsby and Sons with Ruston, Proctor and Company. in 1918. It specialized in oil, diesel, and gas engines, which powered agricultural machinery, locomotives, and generators worldwide. The company was also significant in the development of heavy industrial equipment. Its intellectual property, IP, encompassed numerous patents in engine technology and mechanical engineering, which influenced global manufacturing and powered industrial modernization. At the Cool Spring Power Museum, one of the most fascinating working exhibits is the cooling water system, where 5 Otto gas engines are set up under load to pump water for the larger engines on display. These Otto engines, dating from the late 19th to early 20th century, represent some of the earliest practical internal combustion machines. Each is coupled to a pump, turning steadily under the strain of real work, lifting and circulating water through heavy iron piping to keep the museum's massive stationary engines from overheating. Running under load, the Ottos reveal their true character: the deep, rhythmic exhaust, the measured flywheel momentum, and the steady push against the pump pistons. It's not just demonstration, it's how these machines were originally intended to operate, supplying essential services to industrial plants, factories, and utilities. At Cool Spring, visitors can experience the engines not as static relics, but as living machines doing a vital job. The sight of 5 engines working in concert, belts taut, pumps clanking, and water rushing, provides a rare glimpse into the early era of gas power. It's a reminder of how innovation in engine technology once transformed industry, with Otto's design at the very heart of it. The Ranger V1710 was an American inverted V12 aircraft engine developed in the 1930s by the Ranger Aircraft Engine Division. Compact and air-cooled, it produced around 500 to 600 horsepower. It powered experimental and light military aircraft, notably the Curtiss XP-55 Ascender, but limited demand curtailed its widespread use. The Dormund V12 is a rugged 12-cylinder diesel engine often used to power large generator sets. Known for reliability and longevity, it delivers substantial output, several hundred to over 1,000 kVA, and is commonly found in industrial and backup power applications. The 20 HP Street Mary's oil engine was a robust stationary power unit manufactured in the early 20th century by the St. Mary's Machine Company of St. Mary's, Ohio, USA. These engines were widely used on farms, in mills, factories, and small industrial plants where dependable mechanical power was required before the widespread adoption of electricity. Rated at 20 horsepower, the engine was designed to run on kerosene or distillate fuels, making it economical and practical for rural users. Its construction was typically heavy-duty, with large cast-iron flywheels to ensure smooth operation and steady power delivery. The engine operated on a low speed compared to modern machines, which gave it longevity and durability. Cooling was often achieved through a water hopper or circulating tank system. The St. Mary's oil engine was valued for its reliability, fuel efficiency, and ease of maintenance. It powered equipment such as threshers, sawmills, pumps, and generators, contributing greatly to agricultural and industrial productivity during its era. Today, surviving models are considered prized antiques, often restored and displayed by collectors at engine shows. The 20 HP model stands as a symbol of early American ingenuity in providing affordable and practical power solutions. The Crossley JB benzene engine was an early internal combustion engine produced by Crossley Brothers Limited, one of Britain's pioneering engine manufacturers. Introduced in the late 19th and early 20th centuries, the JB series represented the company's move from gas-fueled engines toward benzene, petrol power, reflecting the growing demand for portable and self-contained power sources. Unlike stationary gas engines, which required a town gas supply, the JB benzene engines could operate independently, making them highly suitable for rural and industrial applications where gas mains were unavailable.
At least we are going to see something.
These engines were typically single-cylinder, water-cooled units designed with the robust engineering that Crossley was known for. They featured reliable ignition systems, efficient carburation, and a compact design that made them versatile for use in workshops, small factories, pumping stations, and even agricultural machinery. The adoption of benzene as fuel provided greater flexibility and mobility, an essential step toward the widespread use of petrol-driven equipment. The Crossley JB benzene engine played an important role in bridging the gap between early gas engines and the development of modern petrol engines. It demonstrated Crossley's commitment to innovation and contributed to the broader acceptance of internal combustion technology in everyday industry and transport. At the 2013 Nieuwenan show, one of the highlights for enthusiasts of early motorcycling history was the demonstration of the V2 Defies twin-cylinder machine. Built in the early 1900s in Belgium, the V2 Defies is an extremely rare example of pioneering motorcycle engineering, and its appearance at Nieuwenan drew considerable attention. The machine, with its distinctive V-twin engine and exposed mechanicals, represents the experimental spirit of the era when inventors were still defining what a motorcycle should be. A memorable moment came when the bike was started by hand, a process that perfectly illustrated the challenges faced by early riders. Unlike modern motorcycles with kickstarters or electric ignition, the V2 Defies relied on careful hand cranking and adjustment to bring its engine to life. Spectators watched closely as the operator primed the cylinders, adjusted the controls, and gave the heavy flywheel a determined swing. After a few tense moments, the motor responded with the characteristic chug and rumble of an early twin, to enthusiastic applause from the crowd. The hand starting of the V2 Defies was more than a mechanical exercise. It was a step back in time, connecting modern enthusiasts with the ingenuity and persistence of the pioneers who helped shape motorcycling as we know it today. The Union gas engine with dynamo was an important innovation in the early development of power generation systems. A gas engine, fueled by natural gas, coal gas, or producer gas, served as the prime mover. Unlike steam engines, which required large boilers and constant water supply, gas engines were more compact, cleaner, and easier to operate. Union Gas Engine Company, established in the late 19th century, specialized in building reliable stationary engines for industrial and marine use. When coupled with a dynamo, an early electrical generator, the Union gas engine could convert mechanical energy into electrical power. This combination was widely adopted for small-scale electricity generation before the widespread use of large steam-driven power plants. The dynamo produced direct current, DC, which was used to power lighting systems, machinery, and early electric motors. This made the gas engine dynamo set especially useful in factories, workshops, rural areas, and ships where centralized power supply was unavailable. The Union gas engine with dynamo represented a transitional technology bridging mechanical and electrical power. It offered independence from large utilities, reliability in remote locations, and flexibility for various applications, laying the foundation for modern distributed power generation systems. The firm Scharrer and Grobe of Nuremberg, Germany, was a respected manufacturer of small stationary engines in the late 19th and early 20th centuries. Their products were widely recognized for reliability and compact design, serving the needs of workshops, small industries, and agricultural users. Among their most notable creations were the so-called second-run engines, produced during the company's second production phase when demand for small internal combustion power sources was expanding rapidly across Europe. These engines were typically atmospheric or early hot tube ignition types, reflecting the transitional technology of the time before electric ignition became common. They were built with precision castings, sturdy flywheels, and careful machining that gave them a reputation for smooth running and long service life. Scharrer and Grobe engines were often sold to local tradesmen and farms around Bavaria, though some units were exported. Collectors today value second-run Scharrer and Grobe engines not only for their engineering quality, but also for their historical significance, as they represent the evolution of German small engine manufacture. Surviving examples are rare, making them prized artifacts of early industrialization in Nuremberg, a city known for its innovation in mechanical engineering. The Cugnot Fardier à vapeur, built in 1770 by French inventor Nicolas-Joseph Cugnot, is often recognized as the world's first self-powered road vehicle. Unlike traditional carts drawn by horses, Cugnot's creation was a steam-powered tricycle designed specifically for military purposes. Commissioned by the French Army, the vehicle was intended to transport heavy artillery pieces more efficiently across battlefields and supply routes. The vehicle, known as the Fardier, a heavy cart for hauling artillery, was powered by a two-cylinder steam engine that drove its single large front wheel. Mounted above the wheel was a massive copper boiler, which produced steam to move pistons and generate mechanical motion. The design allowed the vehicle to move at about 2.5 miles per hour, 4 kilometers per hour, which, though slow, was remarkable for the period. It could carry several tons of weight, making it potentially useful for hauling cannons and ammunition without reliance on horses. Despite its innovation, the Cugnot vehicle faced several limitations. The boiler required frequent stops for reheating and refilling, limiting its continuous operation. Its heavy front-mounted engine made steering difficult, and the vehicle was prone to instability. In fact, during a trial run, the machine reportedly collided with a stone wall, often cited as the world's first automobile accident. Nevertheless, Cugnot's invention marked a milestone in engineering history. It demonstrated for the first time the feasibility of using steam power for land transport. Though the French military ultimately abandoned the project due to its impracticality in field conditions, the Fardier paved the way for later innovations in automobiles and mechanized military transport. Today, one of Cugnot's original prototypes is preserved at the Musée des Arts et Métiers in Paris, celebrated as the ancestor of modern vehicles.